Good afternoon. I'm Megha Singhal. I've played various roles starting from release automation engineer, moved to DevOps, and then got the heat of escalations as escalation engineer. Now I'm working as senior site reliability engineer at NVIDIA. Here I'm managing Kubernetes on bare metal. I started learning Kubernetes back in 2018, and honestly still learning because it is ever-evolving environment. I'll hand over to Gulshan.
Hi, I'm Gulshan Khatri from NVIDIA. I started my Kubernetes journey back in 2019 actually, when I created a 10-node small-scale cluster. And I learned by actually scaling that cluster to 2,000 nodes over the years. So I've seen all of the issues which happened along the way, like challenges with scaling CNIs, configuration management, scaling API servers themselves, securities, upgrade issues that happened along the way. Today, I lead a development cloud infrastructure SRE team at NVIDIA. And today we are presenting a case study to you on how we at NVIDIA use ClusterAPI to simplify Kubernetes lifecycle management. Right? In our agenda for today, we are going to cover the challenges that we face with siloed operations, how we use ClusterAPI for standard declarative cluster definitions, adopting Helm along the way for cluster lifecycle management, embracing GitOps, and key takeaways from our journey. Now, NVIDIA development teams required access to GPUs and engineering boards in Kubernetes clusters. And they had been creating and managing hundreds of Kubernetes clusters individually. Provisioning clusters in isolation resulted in siloed operations and non-standard processes. A wide variety of tools were used to create and manage these clusters, for example, QSpray, kubeadm, through some Ansible automations, or even manage Kubernetes services. Now, individually managing Kubernetes clusters requires teams to have dedicated Kubernetes experts, which is a challenge. Hence, decentralized management of clusters created an increased operational overhead. Right? And so we decided we needed a solution which can do a cluster lifecycle management at scale for on-prem infrastructure. Right? With a quick raise of hands, how many of you have know what ClusterAPI is? And how many of you have either evaluated or used ClusterAPI in past? So I see quite a few of you. Right? So ClusterAPI is a Kubernetes sub-project which provides declarative APIs and tooling to simplify Kubernetes lifecycle management. Now let's see how we use ClusterAPI. As you can see in the diagram, users set environment variables in a file and generate the cluster configuration YAML using ClusterGutl, which is a CLI for ClusterAPI. Users push the generated cluster configuration YAMLs to Git to use it as a source of truth for cluster configurations. Users then apply the configuration on ClusterAPI management cluster, which in turn automatically provisions Kubernetes workload clusters using the desired infrastructure. In ClusterAPI terms, management cluster is actually a Kubernetes cluster that manages the lifecycle of workload clusters. And workload clusters are the Kubernetes clusters which are created by this management cluster and managed. Now, ClusterAPI framework actually provides a way to extend support for any infrastructure. For example, you can bring in your own infrastructure, your own bare metals, cloud providers, VMs, or even Docker containers to create Kubernetes clusters. As most of the teams at NVIDIA needed in-house GPUs and engineering boards to create from Kubernetes clusters, we developed a custom infrastructure provider specifically tailored for on-prem infrastructure. Adopting ClusterAPI helped us automate cluster provisioning, streamline upgrades, and scaling Kubernetes clusters with declarative definitions. ClusterAPI framework provided a seamless integration with NVIDIA's infrastructure, NVIDIA's Intel and engineering infrastructure, and we actually did not require a lot of tools development to integrate it. Right? Embracing heterogeneous clusters. Right? Today, with ClusterAPI, we are able to support multiple kinds of machines. For example, CPUs, GPUs, TEGRAs, or ARMs, all in one single Kubernetes clusters. For the further slides, I'll hand over to Megha.
Thank you, Gulshan. So as Gulshan showed you all, users can generate templates to create workload clusters, but this came with its own learning curve and complexity for users. Hence, as a next step towards reducing complexity for users, we encapsulated the ClusterAPI templates within Helm charts. So how many of you use Helm today? All of you, most of you, actually. So this will be easier to understand. This approach introduced a single point of configuration, values.yaml file, which is very similar to all the Helm charts. And here, in this case, this YAML file was used to define the clusters. By doing so, we not only just reduced the complexity, but we further streamlined our deployments. We also eliminated issues caused by manual modifications to template files. This process has also simplified our upgrade process. How? Users can simply update the necessary parameters in values.yaml file. For example, if they want to upgrade Kubernetes version, they just need to update the parameter related to Kubernetes version and perform Helm upgrade. This change made cluster lifecycle operations more predictable, consistent, and user-friendly. Now, this slide represents the before and after view of user interactions following the adoption of Helm charts. Earlier, as Gulshan explained to you, users had to manually generate cluster configuration templates using cluster-ctl CLI. This involved setting up environment variable files and running template generation scripts, which could be error-prone and time-consuming process. With the introduction of Helm, this workflow was significantly simplified for us. Now, users only need to populate the values.yaml file, which has cluster configuration, and use Helm's native commands to provision and upgrade or update the cluster. A key aspect which remains unchanged is pushing configurations to Git. This ensured that Git continues to serve as the single source of truth for all clusters configuration. Now, to further enhance the cluster lifecycle management process, we integrated FluxCD to streamline operations and fully adopt GitOps model. With GitOps, users no longer perform manual operations directly on management cluster. Lifecycle operations are entirely Git-driven. Now, what has changed is users simply define the cluster and machine configurations in values.yaml file, which they were doing earlier also after adopting Helm. But what has changed is now FluxCD continuously monitors the repository, detects these changes, and applies the configuration corresponding Helm releases on the management cluster to provision the required workload cluster. And it also updates and upgrades as per the state defined in Git. Here are few key takeaways from our journey of adopting ClusterAPI, Helm, and FluxCD. The very first one is standardized operations. By leveraging ClusterAPI, Helm, and FluxCD, we centralized and standardized the entire cluster lifecycle management process. Clusters are provisioned automatically through FluxCD by simply committing configuration to Git. Second one, declarative clusters. ClusterAPI allows us to define clusters declaratively in a YAML file. Additionally, configurations are defined in Git, which acts as a single source of truth for the desired cluster state. All configurations are version controlled, ensuring traceability and consistency. Third one, operational efficiency. The automated provisioning and management of clusters significantly reduced both the operational overhead and the complexity associated with manual cluster management. Fourth one, scalability. We have been managing around 75 clusters with this approach today and still scaling. Last but not the least for any organization is security and compliance. All cluster operations are GitOps driven, eliminating the need for direct manual actions by the users. With automated drift detection mechanisms of FluxCD, we are able to ensure alignment of actual state with the desired state. Now, these are our few references which you can go through. Thank you so much. And we are ready for the question and answers if you have any, and you can connect us on LinkedIn. Thank you.